Hi there, this is Penelope. This is a short video on finding the centroid of a regular shape. Now this is not a maths video, this is a video for fundamentals DE4101 I believe. And it's because so many of you have asked about this that I'm making this short video for you. The one in question, now it's not original, I didn't do the drawing. I didn't make up the numbers, it's from a video that I found, but I will talk you through it. We have here an unequal I-beam. The top flange is 20 millimeters by 10 millimeters. The web, the bit in the middle, is 15 millimeters wide, and the bottom flange is 100 millimeters by 20 millimeters. I've put the axes in red, so here's the axes, and here there's one. And there's the other, you can see them there. The overall height of this is 250, so that means that distance there then we can work out as being 220, simply by subtracting the 10 and the 20 off 250. And we need to find X bar and Y bar. There's no formula directly for this, so what you have to do is divide it up into regular shapes that you can work with. So there's 1, 2, 3, so 1, 2 and 3, and we need to find the area of each of those bits and then find the location of the axes for both directions. So let's look at 1 first. The area of 1 is 100 by 20. And x1 is going to be the location of the y-axis. It's going to be halfway along this 100 meters. So half of that is 50, or 100 over 2 to start off with. And we'd do the same for the y1. Now this is 20 millimeters up here, so it would be 20 over 2, which is 10. Do the same for area 2. The area of rectangle 2 is going to be 15 times 220 millimeters. So that'll be 3300. How about some units? Millimeters squared. X2 is also going to be halfway along 100, so that would be 50. And Y2, now Y2, you've got to start with the 20 at the bottom and then add on half of the 220, so up to about there. So that would be 20 plus a half of 220. And then for the third rectangle, the top flange, excuse me, A3, area 3 is going to be 20 by 10. And X2 is still, X3 is still going to be halfway along the 100, so 100 over 2, and Y3 is going to be all of the 20 millimeters, all of the 220 plus half of the 10, so it would be 20 plus 220 plus half of the 10. Okay, putting all that together then to find X bar first up. X bar is going to be A1 X1 plus A2 X2 plus A3 X3 all over A1 plus A2 plus A3. Now this is the general formula. You're just finding the area times the x1, and the area times the x2 and the area times the x3. So it's the sum of the areas times the relevant x divided by the sum of the areas. That's how you would write it in the general form. Okay, if you put in all the numbers there, you're going to get, let me see, you're going to get 2000 times 50 plus 3300 times 50 plus 200 times 50, and you're going to divide all of that by 2000 plus 3300 plus 200. And then using your calculator, the top line divided by the bottom line, and you get, well, what a surprise, 50 millimeters, which you kind of could have figured out that it was going to be halfway along that 100. The y you're going to do in the same way, only it's going to be a1 y1 plus a2 y2 plus a3 y3, and again the bottom line is going to be a1 plus a2 plus a3. And if you put the numbers in, this time it's not a nice number, it's 90.545, depending on how many DPs you need the answer to. So if we were to put that on the diagram, then the x is going to be on the line at 50, somewhere along here, and then the y is going to be at about 90, which is about, say, there. So about there is going to be your x bar, y bar is going to be your centroid, so that this height here is then the 90.54, 90.55, whatever, and this distance from there is going to be 50 millimeters. Hope that helps. That's just a very basic one, finding the centroid of a shape that's made up of lots of regular shapes. By the time we get to maths, we'll be doing, sorry, I was just checking the time of the video. By the time we get to maths, we'll be looking at shapes that are not regular. We'll be looking at shapes that may be like that. And it's the same idea. You add up all the bits, but we won't be using this symbol anymore. We'll be using this, because we have to take tiny, 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 tiny shapes, tiny rectangles, rather than regular ones. So we're doing this later on, week 13. Okay.